Okay, so hello everyone, and welcome to the lecture 3 of this Python course. And I hope you have listened to the first both lectures before coming to the third lecture. So we have covered how to install Python in your machine yesterday and some other things. Uh, we have checked whether your machine has Python or not from your terminal, and then we have learned that we will use Python and we will run it on an IDE environment with naming the files with an extension of .py, which is a .py script, right? And then we have understood the syntaxes of basic syntaxes of print and input statements, just the beginning. And then we have given a slight info about comments and the difference between both runtime error and syntax error. So that was what we have discussed yesterday, and today we're going to go a bit deeper into the syntaxes and the other concepts of Python. So we will be discussing about variables and how to declare them, what is happening underneath. So yesterday actually we have used an analogy that was that when you create a variable, there would be a bin like structure, I mean a bin or a container or anything, and when we assign a value to it, a value will be stored to it. That is intuitive and somewhat okay, but today we'll be learning what really happens underneath while Python is operating on our machine, and we'll be talking about how we reassign the variables and what will happen when we reassign variables, and we'll talk about different data types, integers, float, strings, and all. And we'll also talk about dynamic typing, which is a good feature of Python, one of its strongest features, the biggest advantage. And we'll be talking about typecasting, like how we change from one data type to another data type, and some naming rules, which are for the keywords. I mean identifiers, not keywords, sorry. So let's start today's lecture from variables and the real analogy. But before that, I'd like to just revisit the print and input statements once again so that no one has any confusion left in their minds. So I'd like to start with print statement. So when we are talking about print, we need to write print with a set of parentheses, open and closed, and anything that we need to print to the output should be inside these parentheses, right? Inside this parenthesis. In that we can print numbers, we can print strings, we can print anything. For strings, we need single quotes or double quotes around them to let the machine know that we are going to bring a string in, right? Now, the full syntax of a print statement is we will print whatever we want, we will mention the end to what it should end with and the separation. So it should look something like print sample text, a comma, whatever you put a comma in the between two things that you need to print, the separation will be, for example, here I want to keep a separation of front slash, right? Then this comma will link to the separation, and a separation will be placed between this and this while the print is taken place, right? And then we need to end it with something. So this is the syntax of a print statement. You'll give print a closed set of parentheses, you will write whatever you need to print, a comma with sep equal to and whatever you need to separate it, and end, I mean comma and end, and whatever you need to separate it with, I mean end it with, end the print statement with, right? That was what a print statement will look like. And now we're going to talk about input statement. For input statement, you put an input, a closed set of parentheses, here, for example, if you want to talk to the user, like if you want him to enter his age, you can print to the output like that. So like you can put double quotes, of course, as it is a string. When you're talking something, it will obviously be a string. Enter your age, enter your age, and then you can close this. What will happen is that this statement will go to the output as enter your age. It will go like this, and it will take an input from the user. The user will enter, and that if you want, if you can later store it into an variable, and that variable, if you want, you can print that variable, or you can deal it with anything you want. The major important thing that we did not focus a lot yesterday was that the input statement is always default by a string data type, right? Whatever the user types on the string on the input, it is always stored in string data type only. So if we need to use make use of the data which is coming from the user in the way we like, we need to change it in the way we like, right? What I mean is that, so the user is giving you 27, but you need to make additions or any calculations with it. If you want to make any calculations with it, how are you going to do that? If it is a string, it is defaultly taken like this. The user is typing this, but the machine is automatically attaching double quotes to it underneath. It is taking it as a string. So whenever you need to make use of it, we use casting. We deliberately change the data type of the input we have. So whenever we have input, maybe if you want only an integer, you take int of input. For actually input has another set of parentheses, right? So int of input. In those ways you can write. So we will go deeper into this in this lecture. This is just an intro, like why we need casting and all. Just a basic reason. It might not be the only reason, but it is one of the reasons why we do casting, right? There are many reasons. Um, and there is also an automatic casting. For example, you've typed 27, and you're forcing sometimes that you need a float. The machine needs float, so it changes automatically to 27.0. Nothing is being lost, right? So sometimes there are automatic casting which is done by the machine, and which does not make any change to the number. Okay, there are some cases like that, and some cases in which we deliberately do. For example, if there's 27.4 and we do casting of it to integer, we are losing some data, right? So in that way, so let us get into the third lecture's introduction, right? Variables. So whenever we have a data, we need to store them somewhere so that we can make use of them again and again, right? So if you have maybe a number called 5 or maybe 67 or 27, and you want to make use of it many times, so you just can't always type 5 and waste your time, right? So sometimes we make use of variables which can store the data while we are writing our programs. We can name them. So in yesterday's analogy, we have told that there is a container, and there will be a container, and when you name for example a is equal to 5, what does this mean? There is a data called 5, and that 5 is going to be assigned to a. It is like a container, so this container is a, and 5 is being stored in this. We have used this analogy, but the point is this is intuitive but not accurate. So we're going to talk about the reality, what is going to happen. See, whenever there is a 5, so for example you have defined 5, this 5, this is an integer, so it will be of 4 bytes. memory. It takes 4 bytes of memory default by default. Okay, integer takes 4 bytes of memory generally. A long int takes 8 bytes and etc. You'll be learning about more about them detailed later in the course. So when an integer takes 4 bytes, every data, every discrete data will be given a unique ID in Python. So when you assign it to a variable, that variable is linked to this unique ID. That's it. There is no container at all. So for example, and then later you just assign a to another string, for example hello. This is also stored somewhere in the memory in the machine, right? This is also stored somewhere in the memory. This has a unique ID. Now what happens is that this a is left from here and attached to this ID again, a new ID, right? And this is left dormant. The 5 is left dormant. What will happen to 5? Once the session is terminated, and now this is now the hello is assigned to a, right? After reassigning it, but before assigning it was unique. After assigning this will be 5 will be a garbage value. It has nothing, it has no significance to identify. It has unique, it used to have unique ID, but we cannot identify it using any variable or anything, right? After the session is terminated, the 5 will be erased from the memory. The memory occupied by 5 will be erased. It is a garbage value till the session is not terminated, right? It was just dormant, it was not used. That is how the memory occupation and how the variables are um, assigned and reassigned. But so we have understood, right? Every variable is like an object. The object is linked to the data, and every data has an ID and memory in the machine. Right? This is the overall thing that is happening. Okay, I hope you've understood this point, and let us get into the next thing. Okay. So we have cleared this here. So a variable is a box that holds a value, right? It's intuitive. This is what we have said before, but this is not the right thing that is happening. Like in the later course, you'll be using oops concepts, and it will not make sense to you that time. So we'll be going with the right concept from the beginning. So in Python, a value like the number 5 lives in a memory as an object. A variable is a name that is just pointed to that object, and assignment does not put value in anything, right? It is just binded. So there is just a link between the variable and the object file, the data. See, so when we are reassigning, it repoints the name to X. That's it. Okay. For example, you have suitcase, right? Even if you name, see, you have suitcase. Let's assume you have a suitcase. What kind of suitcase is this? But if you put a tags on it, you have a tag here and you have a tag here, right? But it's the same suitcase. So even if you keep multiple identities for the same value, it is the same at the end. So all of these data are same, right? It is 5. It has the same ID. It has the same memory. It is the same object inside the Python memory. It is just reassigned by different identifiers. So one suitcase, different labels, but the suitcase is same, the object is same. Did you get it? That is why this does not create any fake memory inside the Python, right? It is just reassigned. The address is all that matters in these type of cases, right? Okay, now let us get to the next thing. Give me a second. Okay. So everything that we store inside the Python, everything that we are dealing with, I'm sorry, everything we are dealing with is an object with three properties, right? Everything, every object has three properties. One, it has an identity. It has an identity. I mean, where it lives, right? As I said, you everything has a unique memory, right? It is stored inside the machine, so it must have a unique ID where it lives, so that we can show the identifier or the variable that where the object or data is living inside the memory, right? It has a unique address, so that is ID. Here Python, every data or object has a unique ID, so that we can show it, right? And then its identity, it has its identity, it has its type, right? I mean, everything has a type. It's what type of data we are dealing with. Is it an integer, is it a float, is it a string, is it a complex number, or whatever we're dealing with? It has a type, right? Is it a, we will deal with some other data types in Python later. They will be like, is it a dictionary, is it a set, is it a tuple, is it a list, etc. We'll be dealing with them in the next lectures. And its value, what is the actual data, right? What is the actual data, where is it living, what type of data is it, and what actually is the data, right? Those are the three things that every object must and will have, right? So for example, we have x is equal to 42 right here. So if we try to print all the three of its characteristics here, print of parenthesis, this type is, this is called type function, right? This is called type function. If you can see, this is called type function. Type parenthesis your object, I mean the name. Here we have x, type of x, it gave you int. This is the output that you got when you used type function. I mean, you printed type function of x, it gave you int. That means this is an integer type, so it has an address. And where is the address? You use id function. So you got the address, you got the type, and the value is 42. If you just print x, you'll get the value also. Value, identity, and type. Okay, we don't use much in the id in the real code, because we don't need, like, we don't need address to deal with it, right? We just need the value and its name. We just deal with it. The memory is just the underlying mechanism which is happening inside where it is stored. We don't need that to code with it, right? Yeah, next. So now what we did here is two tags on one suitcase. I have already explained this. If you reassign, nothing is happening. It is the same object and it has the same memory, so it has the same ID. Nothing is changing in it. Okay, you don't need to calculate, complicate it. I'm sorry, right? So we don't need to care that much about the reassignment and all, right? So this was about assigning and reassigning and variables. So this variable is nothing but it is a meaning that we're a way that we are identifying the data. We are binding it to the data. That's it, right? Yeah. So we were done with the variables and real analogy and reassignment also. I'll be covering in the code at the end of the video. I mean towards the end of the video, and we will have some practice problems too. But let me just clear the concepts and understanding first, so that it will be easy to write your code and think on your own while solving the problems. So that way you can get some real problem solving mindset and some logical thinking from the base, right, as you're learning from the basics and for the first time, right? So we will be heading towards the data types that we have, and also the how we change the data types and all, and the at the last we will also discuss about the naming rules for the variables. Yeah, okay, so we're going to continue with the data types. I have this table for you. We have different data types like integer, which represents all the whole numbers, right, along with the negative numbers, of course. We have all from 0, the positive numbers, the negative numbers, basically, which are not decimals, right, which are not decimals. And that is one data type, integers, which are used only by int. You can't type integer, right? You can type only int. Whenever you use an integer data type, you have to type int. I mean, generally in Python you don't need to. That is a very good advantage. You don't need to mention data types. Python is dynamic programming language. What do you mean by Python is dynamic programming language? Generally, when you code in C, C++, Java, and some other languages, you need to deliberately mention the data type you're dealing with. Like even if you're printing, there you need to mention the data type. If you're taking an input, you need to mention the data type. There are type identifiers, there are format specifiers, and many things. We need to always deal with mentioning the data types, and it takes a lot of effort personally. But Python automatically detects the data type and changes itself accordingly of whatever data we type into it, right? That is a big advantage. So Python, that's the reason they say Python is dynamic. It changes along with what data we provide and whatever data type we deal with, it deals with. Okay, and that is why it is called dynamic programming language. So now that you know the definition of dynamic programming language, you just need to know the data types. We may not use these names specifically, right? We have a float data type, which is indeed just for decimal numbers, right? Like 3.14, like value of pi, I mean, of course approximated, minus 0.5, 2.0, anything. It can be negative too, and in this also the integers also can be negative, and the floats can also be negative, negative, positive, and we get strings. Strings are we for strings we use str, which is like all the text we get, all the characters, whatever special character, whatever you have on keyboard, aside from number. You can actually store anything inside strings. Okay, you can type anything inside strings, but just in Python it is enclosed by quotes, single quotes, double quotes, or triple quotes, right? And bool, this bool is boolean values, which is like true or false. If you have studied semiconductors in your 12th, you might have read about the boolean values. I mean, I've already explained in the first lecture, right, about the on and off, right, true and false. It is into that values, and there are some logics too, where we will later get into the videos. Like we have or logic and logic. It is between the zeros and ones only. True and true, true and false, or false, like that. We will get into boolean data type. And the last one is none type. This means that there is no value, like a void. nothing is there. Okay, these are the 5 data types that you need to know. These are fundamental data types, and then we will get some other storage types like lists, dictionaries, tuples, and sets, and etc. Right? So okay, so I want to show some good things, good facts type of things for you guys. So didn't you get a doubt, like in math, at the end of the day, either you take an integer or you take a decimal, everything are just real numbers, right? Everything is on the number line, number system, right? Why do you need a separate data types for that, float or int or etc.? So the fact is that the numbers are not saved in the same way. For example, if there is an integer, you have an integer 17, it is saved as exactly as 17. But when you have a float number, sometimes the machines are optimized in such a way, and they can, as so that they can save very huge or very tiny numbers in the machine. Okay, they are optimized in a certain way so that they can save extreme kind of numbers too. Okay, so for example, if you can see, so as they are optimized in that way, there are some errors in the slight differences between the real values. So for example, if I click print 0.1 plus 0.2, let us see how much value it will give us, right? See, 0.1 plus 0.2 gives us not 0.3 but a slightly larger value, right? So this is a proof of why, like, we have two different data types, because the float values are slightly different from how integer values are stored inside the memory. There's a slight optimization. So this is your homework for today. I want you guys to research about why float and int, when we can have a single data type like math, right? Why two different things, and why the underlying real mechanism. I've told you that, but I don't have time. I have only 1 hour for this topics, and I can't keep teaching everything that keeps happening under the hood, right? Why 0.1 plus 0.2 in Python prints 0.3 at the end 4, 0.3 4. Why is it printing like that? And is it only in Python, or is it the way that all programming languages store the memory like that for floats, and they print the same way? Do a research about it and go as deep as you can. Okay guys, go as deep as you can. You're just starting to learn Python, and no worries, you can learn sometimes what things happen under the hood. You can go forward, I know, but you can go deep inside some things which will give you a clarity which most of the people don't have these days. Okay, so and then we're going to talk about another fact which we had here. When you print, see, generally in programming languages, we are talking about 0 and 1 as true and false, right? True and false. Sorry, false and true. True means charge is there and this is discharge, right? So 0 is 0 and 1 is anything present, right? Anything present, I mean anything being present is being 1, and being charged and being true, right? So let us see what we can get if we print true plus true, right? Is it capital T or small t? It is capital T. And the boolean value false and true are capital F. Right, let us see what value we'll get here. So we get a value of 2. So true value is 1. But the general logic is anything non-zero, it might be greater than 1 also, it will be true. Okay. But if you print the value of true deliberately in Python, it will give you 1. Okay. Next. So this was what we said about dynamic typing. Dynamic typing in Python. So we don't need to mention the data type. In some languages you must declare variables data type, and but Python is dynamically typed. So you can redeclare x many times. See, you declared it with 5, you declared it with a string randomly, you declared it with true, but you didn't ever mention the data type here, right? But if you do this in C, for example, you had to mention int x is equal to 5 semicolons. For example, if you are doing string here, for that we need another jargon. We have to do a lot of things for that. If we have this, we need to do bool x is equal to true, like that. We have to do a lot of things in other languages, and you have to be lucky that we are having Python. I mean, everything has its disadvantages and advantages, but Python is very good in this point of view. Like the syntaxes are very easy, and it is dynamically typed, right? Close to English. Okay. Next thing. So another misconception that most of the beginners feel is that I also used to feel like this, that once we have our variable and we have reassigned it to other thing, like when we are coding, see, previously we wrote x is equal to 5, x is equal to true, and x is equal to myth, for example. I'm talking, you'll think that it is reassigned, x has been reassigned to the object true after from 5, and then again after from true to myth. So you think it will be in the previous log or something, some kind of ledger which will have the previous data. No, as soon as this x is associated with the myth id uniquely, this becomes, just forget, you'll just forget about this. This becomes garbage. It will just get terminated in the next session. That's it. Okay, all that matters is only this now. Everything that matters is only this now. I hope you understood. And I think this is it with the data types and dynamic typing, and we'll discuss about casting and naming rules also in 1 second. Wait. Okay, yeah, so welcome back, and we'll be continuing with the casting and naming rules of the variables. So if you look into this particular example, here we have age underscore text is the variable name here, and 21 has been assigned as a value to it, right, as an object to it, right? Now what is 21 here? It is not a number, it is a string, because it is covered in quotes, it is covered in double quotes, right? It is covered in double quotes. If you see here carefully, double quotes are there, so it is a string. Now we want to change that string into integer. How do we change it? We have created new variable as age, and we have assigned, see, age text is inside the integer parenthesis, right? So when you have to change the data type of any variable into another desired data type, you can cast it. casting is basically changing the data type into your desired data type, just changing the data type. So for example, if you want an integer from string, you keep int and parenthesis. For example, if you wanted a float, you would have typed float and parenthesis, and inside parenthesis the variable which you would like to change it, right? So next we have printed age +1, it is normal, and then here if you see in the example below, we've created a variable named pi and assigned it to 3.14 as a string. There is a string 3.14 and we wanted a float value of it, so we have typed float, and in the parenthesis we have put the string value of 3.14. I mean, we have done it deliberately to show that what casting is, but it doesn't make any sense. Like, you can directly assign pi is equal to 3.14 and just print it if you want your pi value. I mean, this might have been a case where, like, for example, the string of 3.14 might have been another variable, for example input. It should have been an variable which was associated with an input variable. I'm sorry, input variable, and then we should, of course, it will be taken as a string. So that was how we would have discussed to do this, right? In this way we could do casting, right? We will of course solve more problems on this, but the basic idea of it is to change data types, and mainly it is used when we take input, right? Whenever we take an input but we have to operate it with in other ways, so we just cast the string into our desired data type. Next, and till now we are always I was always mentioning about variables. What are variables actually? Like, how can you name them, and what can you name them, and can you name them however you like, and what are the rules? Like, there will be the rules, right? So I will be mentioning you and teaching you about all the rules that you need to know about the variables in specific. So actually, when you talk about variables, there are two things that you need to know. There are these things called identifiers and keywords, right? So first I'd like to talk about keywords. What are keywords? Keywords are the standard words that are reserved for the language, and you can't use them for the identifiers. What are identifiers? Those are the normal things, names that you can be used for your variables, for your containers, or for the tag that you are attaching to your object or data, right? So we are talking about keywords which are reserved and identifiers. There are a reserved set of keywords for each programming language which we cannot use to name our variables, which are identifiers. Identifier is the name of the variable. You can use it to name a function, you can use it to name an object, you can use it to name your anything, to assign a value, anything that you are using as a variable. The name that you use is called an identifier. You are identifying your object, your variable, your function through that name, so it is called as an identifier. But there are certain words which are not allowed to use in identifiers because they act as a specific function, like they act as a specific task for the programming language, which are standard for the programming language to function, right? And you can't be using them as in a variable. And there are so many reserved keywords for each language, and for Python there are about 33 keywords in Python, as you can see the list here: and, break, elif, for, in, not, true, false, is, from, else, class, like that. You don't need to remember them, because whenever you try to use them in any variable, if you are in a good environment like VS Code or any code editor, unlike TextEdit, it will just inform you that you are using a keyword, and you can just change it out, right? You don't need to remember everything. But as we tend to go towards the end of the course, you'll get to know most of them, which will be not in the keywords, like which will be in the keywords, so you'll not be using them. Okay, so there are some rules that you need to know which are necessary for you to write your own keywords, right? I mean, write your own identifiers, not keywords. I'm very sorry. Yeah. So See, this is the only thing that you need to know for the rules of the identifiers. Okay, whenever you're naming your variable, right, you only need numbers, alphabets, I mean letters, and underscores. You should only use them. You should not be using any special characters like hyphens, asterisks, or and symbol, or dollar symbol, at the rate symbol, anything like that. You should not use any special characters. You should be only using digits, underscores, and alphabets. And one more rule is that the name of the variable should not be starting with a digit. It should either be starting with an alphabet or an underscore, but never a digit. And digits can be in any place, or it doesn't matter, anything, and anything doesn't matter. The variable name can start with underscore or anything like that, but never a digit. And one more thing I want to specify, that here in Python or in some other languages, the names of the variables are case sensitive. And what I mean by that is, for example, if you see here, score, small s score, and capital S score are different. They both are completely different variables, and they are assigned to different objects. They can be assigned to different objects, right? They both are different, they're not the same. And one more thing is that I've already mentioned that you can't use keywords as your variable name. So there are only 3 rules that you have to remember while naming your variable. Is that you can use only alphabets and digits with underscores, but no other special characters, and it cannot start with a digit. And the next rule is that no spaces or symbols, right? It is case sensitive. And the last rule is that you cannot use keywords which are reserved for the language, right? These are the rules of the casting and naming rules, right? We have completed all of them. And now, as I said, as I have promised in the introductory video of this course, that we'll always be doing practice problems at the end of the each lecture after we finish the theory. So we'll be getting into some practice problems. So I advise you to please listen to my explanations also, but before that you need to try to solve the problems on your own. Okay, so let us get into the problems, and let us see what we have. Okay, here we have our first question is this. Ask the user for 2 numbers with input function and convert both of them to integer and print their sum, and remember the input trap from lesson 2. I mean, here let me give you a hint. Input trap they're talking about is nothing but the fact that input statement always takes any data as strings. Here they are telling us to perform sum, addition of 2 numbers, 2 integers. Of course, as they said, convert both of them to integers. So you should have been understood by now that we take strings and they're telling to convert to integer. They are only giving the answer in the question, so we need to convert it to integer and then perform the summation. So you just go to your code editor and try this problem on your own. Let us get into it, right? Yeah, the question was that take 2 integers as an input from the user, right? So I will take an integer. I will name my variable as int underscore 1. Can I name it as 1 underscore integer int? No, we cannot start with an int, a digit, right? So I named my variable and I will take an input from the user. I will tell him to enter your first number. I'm very sorry, your first number, right? And I'll tell him to enter his second number. right? So the fact that is now we need to, okay, so I have made a typo mistake here, right? So now we have taken input from the user. He has entered his first number, he has entered his second number, and now to perform summation we need to change them into integers, right? So I'll do this as I'll just name them AB. Okay, A is equal to, we are using casting here, so A is equal to int of 1, right? And B is equal to int of int 2, right? So integer of, in parenthesis, the thing that we need to convert. So we are converting int 1 will be a string, of course. So we're converting that string into an integer, and the same for the other one also. And now we need to perform addition. So I will name it as sum, and we are performing addition, right? And we need to print it. We need to print it to the output. We will tell him that, okay, your sum is your sum of the given numbers is, okay, we will print, we need to keep a comma, and we need to give the sum in the print statement, right? So I hope this is it. This is how it needs to be, right? So it is asking the user to enter your first number. So I will choose my first number to be 12, okay, and my second number to be 65 maybe. Next. So it has given your sum of the given numbers is 77, right? So if you notice here, I have left a space after here. I have left a space here, right? You see here, and I have left a space here. Do you think the two spaces here are coming due to that? Here we have one space, here we have one space, here we have two spaces. Why? It is a very small question, but see, I'll give you an answer. See how many ever spaces you type here, it does not care about it. Okay, the interpreter does not care about how many space you give after the comma. All it cares about is it prints the string, it searches for the next thing to print. Here we have put a comma, so the next thing to print is sum. We have given nothing to print, nothing for it to print after comma, right? That is separation. So the default separation is comma. So here we have left a space. The default separation is space, I'm sorry. Okay, so here we have left a space in the string itself, and for a comma it will take another string, another space. So that is why we are getting two spaces here. Here though we have left only one space in the string itself, so that it has been doing that. And after that the end will give a new line, so it has been going down, right? So here if we want only one space, what will we do? We will either remove this or keep that and change the, keep another comma and change the separation to nothing. So if we keep nothing in the separation, here we had two spaces, right? 1, 2. We will make it to only one separation, hopefully, right? Here there's no space. I mean, here we have only one space, and for the comma we have made the separation to nothing. Let us see what we'll get. Enter your first numbers. I'll enter the same numbers, 12, 65. Now we have got only one space here. Okay, these are the small things that you can notice. I mean, this does not make any sense to you, but see, okay, when you are learning something for the first time, know the most and cleanest basics, so that you will not face any difficulties next time when you're learning. You can just go further away. So these are things that you need to learn from this. You have learned how to do casting, how to take input, and how to print them. And it could have been a lot more quicker, you know. There's one thing, you can take both of the integers at the same time. See, I've named them int1. I'll do it int1 comma int2, both at a time, and I'll just assign them input, enter first integer, and I'll take the second input, enter the second input, right? Enter second integer. So when we are doing this, we do both declaration and initialization at the same time. So what is declaration? When we set the name of our variables, right, that is known as declaration. And when we assign them some values, it is known as initialization. We are initializing the process of giving the values to the variables, right? We can do it in a single line for multiple variables. Okay, here for int1, int2 we did a comma. So the way that this works is that the values are assigned correspondingly. So for integer 1, the first thing will go. For integer 2, the second thing will go. I mean, we shouldn't be keeping a comma here, so I'm sorry. Yeah, so here is a comma, here is a comma. The first one will go to the first one, and the second one will go to the second one, respectively. Corresponding values go to the corresponding ones. Now we have converted, we have declared and initialized at the same time, and in this same line we can convert them to integers, right? You can be doing casting. When you know that you need to deal with integers, you can just take the input as an integer only. You can do the casting there itself. Okay, this is a quick step. Okay, you have done integer there only. So you have done all of them in a single step. You can just print them in the last. Print int1 plus int2. That's it. 2-line code. I mean, it is very easy. Okay, you don't need to care. That's not what I wanted. int1 plus 2, and they're asking the 12, 65. So we got it as 77, right? We've got the code. Okay, let us get into the next question. The next question is that they've given in a variable a. They've given a set here. Set is nothing but it is another data type. Usually till now we were storing only single datas, right? A single integer, a single string, right? When we have certain methods or data types storing, we can store multiple values, right? We can store multiple values, and there are some specific types we can have, like sets, dictionaries, tuples, like that. In that way, so when you close them with square brackets, there's this thing called set. Just keep it aside for now. So the main ideology here is that he has stored a value in a, and this same a he has assigned it to b. An object we have here, he assigned it to a, and he assigned the same thing to b. So he is asking to print the ID of a is equal to b, ID of b, and he is just telling you to explain the result. So the main ideology that you need to know here is the equal to symbol. If you don't know from before, I don't remember if I've explained it before, so I'll just give you a short recap of it, of what it is. You know what ID is, right? So instead of set, let's just take a random example. A is equal to 7. Okay, and what did he do? He took a new variable and assigned a to it. So at the end of the day, a is 7, so just b is 7. So a is b, b is 7 at the end of the day. So they both are same. We know that, but we need to prove that with the use of ID. What is ID? There is a unique memory allocated for every object in Python. Okay, the object here is only one object, right? It is only 7. We don't have any new object here, so obviously the ID will be same. We have just made two variables for a single object. As what I've said you, even if you reassign or do anything, the ID, the memory will be allocated for a unique object. But here we only have one object, right? If we had any another object, what do we mean by object? It is data, right? If we had anything like 8 or 9 for b, then it would have been two different memories, two different unique IDs for them in the memory, in the machine, right? So now it will be the same. So now we need to print it. So how can we see one thing? If we want to know, if we want to prove it, we can just print the ID of both A and B and then see it with our eyes if the ID is same or not. And one more thing is to do that is, if the ID of both are equal, it can just print true, right? So let's check if those both are equal. To check equal, generally in math, till now I told you here we have an equal to symbol, right? In math, if there is an equal to symbol, they both are equal. And I have told you before that in Python, the equal to is not equal. It is just assignment. It is just pointing towards the object. You are assigning a value to the variable, right? In Python, equal to means double equal to. Okay, and you have also other things like greater than or less than, greater than or equal to, less than or equal to, greater than, less than. I'll be explaining about these more detail in the next lecture, in the coming lecture. Those are operators. These are comparison operators. We'll be learning about them, don't worry. So for now, double equal to means they both should be equal. And the literal meaning in Python of this is that the data type should be equal, and also the values, the absolute values must be equal. Okay, there are two rules. The data type should be equal and the absolute values should be equal. Like for example, if you put equal to between string 7 and integer 7, it would result you a false statement. So these comparative operators result you either true or false only. They result you with boolean values. Okay, so when you keep 7 is equal to 6, it will result you false. It will result you boolean values. Okay, so now we will just take id of A is equal to id of B, right? It is the same thing, so we will just print it directly. Why do we need to make any other variable for this? We are just printing this. Okay, let's see. So it is resulting true. So I have explained to you why this should happen, why they have the same ID, and how you can use usage of ID. You can just click ID, and in parenthesis, these brackets are known as parentheses, and inside that you can just name your variable, and in between you will just keep your operator, which is equal to operator here, which checks the absolute value and the data type. Okay, I also wanna look at this example. I want you guys to look at this example. See, here we have an integer 7 and a string 7, and now let us see if they both have same ID. This is an integer and this is string. Are they stored in two different memory locations? Yeah, possibly, because they both are two different data types. So Python doesn't know if it is the same thing, so it will store in different memories, and they have different IDs. So yeah, they both have different IDs. I mean, they are not equal. So you can also use a not equal to, also a not equal to symbol. This symbol is not equal to. This shows exclamatory is equal to is a not equal to symbol. So now these both IDs are, these actually are not same, and they don't have the same memory. So it should be resulting in true because they are not same, right? Now it will result in true, right? I hope you have understood this. And next, so the next question we have is that swap the values of two variables A and B in a single line without a third variable. So I'll give you a hint to do this. I've mentioned you about initializing and declaration and initialization of multiple variables, right? What you'll do is you just declare A and B and then initialize it with B and A. Simple, in the same line. Okay, I'll just do it and show you. Let us just assume A is equal to 4 and B is equal to 5, and I'll initialize. I mean, we have already declared here. We are declared and initialized here. In Python it is done at the same time. In other languages they first declare it using int a, int b, and then they initialize it with by assigning a value. But in Python we don't generally do that. We do the both initialization, declaration and initialization at the same time. Okay, because we are assigning it the value immediately, right? So now we are going to swap values, a comma b with b comma a. See, now what happened? B is assigned to A and A is assigned to B. So now at the end of the day, the both values are swapped. So now if we try to print A comma B, excuse me, A comma B, we'll be printing the swapped values. See, we have assigned 4 and 5 to AB. Now we got 5 and 4. We have swapped the values, right? And the this question had something error. So these will be your homework questions, and I hope you would be trying this. The questions will be, I'll just read them out for you. Write a profile card program. So okay, you need to ask the user for an input for his name, for his age and his city, and then print 3 tidy lines using values. Make sure age is stored as an integer. Okay, you need to use casting here. And next, create 5 variables of 5 different types: int, float, string, boolean and none type, with good descriptive names, and print the type. It is just usage of type function. Next, explain in 2 or 3 sentences of your own writing why b is equal to a can make changing one variable appear to change another. Use the words object and tag. Okay, you can do that. If you can't, just Google it. Find 3 variable names that would cause an error and explain why. See, we had only 3 rules, right? And he's asking 3 variable names which would cause an error. So you use all the 3 violations and just do it, right? So I guess that is it for today. And thank you so much for staying till the end if you have stayed till here. And we'll meet in the lecture 4. And thank you.